Hi class. So last thing we talked about was a standard unit of measurement in chemistry known as the mole. And we looked at that in regards to the periodic table and how every element we have listed on the periodic table you consider as one single mole. So for carbon, we'll look at that for example. 1 mole of carbon is going to have a mass of 12.01 grams. Don't forget we also talked about how listed on the periodic table, the unit of measurement for mass is really atomic mass units, but that's going to be the same numerical value in grams. So that value, 1 mole with a mass of 12.01 grams, that means that you have a total of 6.02 times 10 to the 23rd atoms of carbon. And this number here, the 6.02 times 10 to the 23rd, that's our Avogadro's number because he was the one who came up with this concept, or sort of figured it out rather. Okay, so that's what we talked about last week, and then the other thing we also practiced was using this measurement to compare the amount of something. So for example, we would know that 1 mole of carbon is going to be less than, say, 36 grams of carbon. Okay, so since we know 1 mole of carbon is a mass of 12 grams, that means that 36 grams of carbon would really be the equivalent of 3 moles of carbon. So that's everything we talked about last time. The next thing I would like to talk about is looking at the molar mass of an entire compound. So we'll just focus on this small little section of the periodic table up here. And let's look at a couple of simple examples. So let's go back to our good friend table salt, sodium chloride. So sodium, if we look on our periodic table, has a molar mass of 22.99. And we'll go ahead and just think in grams. And then chlorine has a mass of 35.45. You add those together and you get a total molar mass of about 58.44. And we'll go ahead and say grams unless we specify atomic mass units. Okay, so this right here, the 58.44, is what you could list as the molar mass for sodium chloride. Okay, let's look at another example. So we have 1 mole of carbon dioxide. You would do the same thing, and you have to take into account how many atoms you have for every element. So for carbon, you have your 12.01. For oxygen, you have your 16, and there's 2 of them. So you need to add that twice, and you would end up with a total molar mass of 44.01 grams. Okay? It's that simple, and that's what I would like you to practice today.